Hello and welcome back to Humanizer, where I'm converting the free and open source MPFB2 3D character creator from Blender into Godot. So this time I'm just refactoring the skeleton builder to calculate the bone positions at runtime from the helper geometry instead of using the pre-generated shape keys, because the pre-generated shape keys take up a lot more memory than calculating it at runtime. It just runs slower, as you can imagine. So I did the skeleton builder this time, and I'll get to the clothes builder next time, and then I'll commit it all to the repository once it's all working together. But now I'll just show you the skeleton builder. First, I need to access the shape key data for each human builder, but I don't want to load that file multiple times because the JSON is very large. But I also can't assign the value of a constant to the return value from a function, even if it's a static function. And you can set a constant to a preload, but the resource saver doesn't work with dictionaries, so I don't think you can preload a data dictionary anyway. So I'm pretty sure the only way to have a single copy of the shape key data will be to use the auto-load global variables. The only issue is the data won't be visible for the tool scripts, but those are separate from the game files anyway, so this is just for demonstration. So I can load the shape keys separately. So I'll go ahead and make a new script extending resource, and I'll call this the data class, and we may need other data sets to be permanently loaded. So because every time the character ages up or gains weight or anything like that, a new character is created, or you load a new chunk, and then so you'll need to be calling the shape key data basically all the time. It doesn't make sense to be constantly unloading and reloading it. So I already have the load shape key data function in my generate close mesh. So I'll copy that, and I'll set the shape key data to the load shape key data, and then in the project settings, well, I'll go ahead and save this. Then in the project settings, under the auto load, I'll open the data. So this will be the data global variable, and now I can access the shape key data from any of my other scripts. Now I want to separate the logic for building the skeleton and the clothing and the collision shapes from the actual human character logic, which will be like the movement and inventory management. So I'll make a new class for the human builder, extending resource, and I'll set the class name and make a new variable for the helper vertex data, set to an empty array. And on initialize, I want to take a mesh instance variable, mesh instance 3D, And I just want to, so I'll need to build the helper vertex array, but for now, I'll just loop over the shape key IDs in the mesh instance get blend shape count, and then I'll want to get the shape key name from the mesh instance dot mesh, and then I'll find the get blend shape name from the ID, and that's because the way I have my shape key data indexed, so I probably need to change that, but for now it's stored by the name, so I'll get the shape key ID, and we'll say if the mesh instance blend shape value at the shape key ID is greater than 0, then I'll print the shape key name. And now in the human character scene, I'll add a new variable for the human builder, and pass the body mesh instance node. So I don't want to pass the human character self variable, because then we'll have a cyclical dependency issue with the human builder. So now if I run this, you can see that it prints out the shape keys that are set. So if I change the race and gender, it prints the different shape keys. Now in the human builder, I'll set the helper vertex data equal to the data dot shape key data dot basis dot duplicate, so we don't overwrite the original array. And then I'll get the shape key value from the mesh instance get blend shape value, and instead of printing the shape key name, I'll loop over the vertex IDs in the data shape key data dot shape keys at the shape key name, and I'll add, so helper vertex at the int vertex ID plus equals the shape key data at the vertex ID. So it threw an error the first time I ran it because the data auto load was extending resource, and your auto load scripts need to extend node 3D because they're actually added as nodes to the tree. So it did take considerably longer to load the project then, but now once it's loaded, you can see that you can still change the age and the gender and the race. It is noticeably choppier when you change it. It doesn't update as smoothly, but you don't really need to update this all that often. Like I said, when the character might age up or gain weight, or whenever you load new characters from a chunk, but they're not going to be constantly changing like this, so it's not that much of an issue. Next, I'll want to generate the skeleton from the helper vertexes instead of interpolating through the shape key pre-calculated skeleton data. So this will actually be more efficient than the previous way. So first I'll need to make a new scene to load the skeleton config from the Mixamo JSON file. And I'll save this in the skeleton builder. And eventually we'll get rid of the load skeleton data completely. So then I'll want to attach a built-in script. And from the load skeleton data, I'll want to load the Mixamo config. Which replaces the bone names, replaces the colons in the bone names with underscores. And then it also will then find the ID of that bone name, since they're all out of order, and just set the bone name to the skeleton ID so that it doesn't have to find that. So the Mixamo rig.json is from the original MPFB2 plugin folder that I've copied into the project, and I've gone over that before, but basically this has all of the position and rotation data for all of the Mixamo skeleton bones, but as I said, these are not in the same order and they don't have exactly the same naming convention, so that's why we have to parse the data. And I also need the skeleton node to get the proper bone ID, so I'll just copy this from the original skeleton data, and I don't need the mesh. So this is the basis skeleton, and then I'll set the skeleton variable to the node path. And this should be on ready as well. And now on ready, I can probably, instead of using the JSON stringify to save the data, I can probably just use the store variable. So I'll use the file access dot open, and I'll want to save this as the skeleton config dot data, and then this will have write access. So this will be the save file, and then I'll use save file dot store variable, and this will be the Mixamo config. So this is not an object. I don't think I need the full objects boolean set, but I might. And then I should be able to just close the save file. So now if I run this, so it threw an error, but I think it's just because the skeleton needs to be defined before the Mixamo config. So I'll try to run that again. and it does seem to take a while. That's because it has to load the shape key data whenever you run anything, but I'll optimize that later. So now in the game dev go.humanizer build skeleton, we have the skeleton config.data, and you can see that it has saved the dictionary in here, so you can see some of these names still that are saved in plain text, and then the rest of it is just compressed. But now I should be able to open this a lot easier without parsing the JSON. And now in the data autoload script, I'll add a new variable for the skeleton config equals load skeleton config, and I'll make a new function. So I'll get the file from fileaccess.open, and I'll pass the skeleton config.data file and with fileaccess.read, and then I'll get the data equals tempfile.get variable, and then I'll return the data. Then in the human builder class, I'll make a new function to build the skeleton, which will take a skeleton 3D, and I'll want to loop over the bone IDs in the skeleton.get bone count, and then I'll want to set the bone position equal to calculate bone position from the bone ID. And I'll make a new function to calculate the bone position. So this will take a bone ID of type int. And for now, I'll just print the bone ID. Then in the human character, instead of building the skeleton here, I'll call the human builder build skeleton and pass the skeleton 3D. So now if I run this, hopefully it will just print out the bone IDs once it's done loading the shape key data. And I will change that so that it loads from a variable instead of the JSON. I just didn't want to break the closed demo. But down here you can see that it has loaded all the bone IDs, so that's good. Now instead of interpolating over the pre-calculated bone shape key positions, I'll be calculating it from the mean or cube vertexes instead. Since I already have the helper shape keys calculated, it just makes more sense. And it will be a lot more efficient, actually. So in the human builder, I'll paste those. Now I don't need the shape name for the average bone vertex or the bone ID. I just need the index array, which has the indexes that need to be averaged. And you don't have to check if it's in the shape key because we're using the helper vertexes instead. So for the blender index in the index array, add the helper vertex at the blender index instead, and then I'll divide the bone position by the index array size since it adds all three to get the average, or this will be 2 or 8 depending if it's a mean or a cube. And I don't think I need to subtract the bone. I don't need to get the relative position, so that should be good. Now for the mean strategy, I just get the 2 vertex indexes from the config and find the position. But for the cube strategy, I have to open up the vertex groups JSON and get the position from there. So if you see in the data rigs standard Mixamo, the mean strategy has 2 vertexes already, and these are individual. This is not a range. But then the cube strategy doesn't have the vertex indices because it is referring to a cube name instead. And you can find that information in the data mesh metadata, and then there's the base mesh vertex groups. So, and at the bottom you can see the joint cubes, and these have a range. So this is 8, this from 13,814 to 13,821 will be 8 vertexes, and I think this is inclusive. So I'll want to substitute this array for the cube name in the rig config file so that I don't have to be referencing this other file when I build the skeleton. So in the load skeleton config, first I'll grab the vertex groups variable from the load skeleton data, and now in the load Mixamo config, I'll check if the out data at bone ID dot strategy equals cube. Then, and this will be in the head, so dot head dot strategy, and I'll just print the bone name for now, and I'll disable the data auto load for now. So now if I run the skeleton data, or the skeleton config, it should hopefully print out the bones with the cube strategy. So that worked. Now instead of printing the bone name, I'll print the vertex groups at cube name, which will be outData.head.cube name. And so this should give us an array of 2 indexes. And you can see this is a nested array, so I'll just want to get the first element. So this will be the first. So I'll set this variable to the cube range. And then for I in range, we'll get cube range at 0 to cube range at 1 plus 1, since the data is inclusive but the range function is exclusive on the last one. So this should give us all of the indexes, and then I'll make a cube index equals an empty array, and I'll add append I to the cube index. And then I'll go ahead and print the cube index just to make sure that's working. It's easier to test as you go versus adding a bunch of code and then testing afterwards, because then you're not really sure where the error is. But this way I know the error is in like the last 5 lines of code that I added. So now we've got all of the indexes for the cube joints. So now instead of printing the cube index, I'll want to set the outData boneID.head.vertex indices to the cube range array, or the cube index array. So I'll let that run again, and then I'll need to update the human builder so it doesn't have to distinguish between the mean and cube strategies. Now in the human builder, I don't have to check for the strategy. I can just set the bone position equal to the average bone vertex, and I don't need the shape name or the bone ID to be passed. And I can get rid of the if statement, and then I'll need to re-enable the data auto load, so these shouldn't throw errors once you run it. And then instead of the Mixamo config, I'll get the data.skeleton config at the bone ID, and I'll get rid of the shape name argument. So now this should all be working, although if I run it, I don't think you'll be able to tell the difference anyway, because I don't have the animation set up yet. And so it threw an error because I've actually already parsed the helper vertex is already vector 3s, so I don't have to convert it. So we'll try running the project again. So it did run without throwing any errors, and you can see that you can still change the age and gender and all that, because it's not actually, so it's not updating the skeleton currently, but because it's not animated and it's resetting the skin transform, you actually can't tell at this point. So now I need to actually set the bone position, and in the human character I need to reset the bone poses first, and then get the parent ID and the parent global transform, and then you multiply the bone position by the parent transform to get the relative position, essentially, and then I'll set the bone position from the bone ID and set the rest pose from the bone position. Then in the human character, I'll want to move the update the skins on the mesh and clothes. So hopefully this will work without throwing any errors. So it looks like it did. The shape keys still work. So I'll do the clothing next time and get rid of those big pre-compiled meshes, and then I'll upload it to the repository. I just don't want to commit half-working code, but that's all for now. Thank you for watching and have a great day.